Okay, these problems are solving radical equations. Well, this is the technique we're going to be talking about, solving radical equations. And it's just an equation with a radical or a square root in it. The only thing about these is we will have to check the answers. Because sometimes during the solution we will introduce what we call an extraneous root. That won't work. So we always have to check our answers. So first of all, if we look at this, the first thing we're going to do is isolate the radical. In other words, it's just like an equation, just like x. If you were solving for x, what's the first thing you do? Well, you would add 5 to both sides. So if I add 5 to both sides, I get 3x, or 3 times, excuse me, the square root of x equals, and then 13 plus 5 is 18. Then I would divide both sides by 3. So again, we just want to isolate the square root. We have the square root of x equals, and 3 goes in 18 6 times. And then we just square both sides. And the square root of x squared is x. And the square root, I'm sorry, and 6 squared, 6 times 6 is 36. So there's your answer, but we need to check it. So we put this, so we write 3 times the square root of 36 minus 5. Does that equal 13? So there's our answer. And what's the square root of 36? Well, the square root of 36 is 6, so it's 3 times 6 minus 5, and 3 times 6 is 18, and 18 minus 5 does equal 13, so that checks. So we don't know for sure, now we check it. So make sure you check these. Oops, sorry. Excuse me if I ran over there. So again, x squared, the square root of x squared is x, 6 squared is 36, so we check this. So every time we see an x, we put a 36, and it checks. Okay, here's another one. This is example 1. Example 2. The square root of 4x minus 3 equals 5. Now, if there was something else over here, we would do like we did up in the example 1. We want to isolate the radical, but it's already isolated, so now all we have to do is just square both sides, okay? And this is just going to be 4x minus 3, and 5 squared is 25. And then we just solve for x. So we add 3 to both sides. So 4x equals 28, then divide both sides by 4, so x equals 7. And then again, we want to check it. So our check. And what was x? X was 7. Okay? And then what's 4 times 7? 28. So does that equal 5? So that's the square root of 28 minus 3. Does that equal 5? We don't know yet. But what's 28 minus 3? 25. And the square root of 25 does equal 5. So that checks. Okay? Oops, sorry about that. That makes sense. Okay, and one more. This is the cube root. Equals 7. So the first thing we want to do is we want to isolate this. So we'll subtract 4 from both sides. So we have the cube root of 2x minus 5. And if I subtract 4 from both sides, that equals 3. And then I'll cube both sides. And the cube root of Something cubed is just going to be that something, so it's going to be 2x minus 5. And 3 cubed is 27. 3 times 3 is 9 times 3 is 27. Then if I add 5 to both sides, I get 2x equals 32. Then if I divide both sides, I get x equals 16. Oops, running out of room here. There we go. All right. So I'll just check it over here. Here's my check. And I've got the cube root. Two times x minus 5 plus 4. Does that equal 7? And my x is going to be 16. So I've got the cube root. And 2 times 16 is 32. Minus 5 plus 4, does that equal 7? Well, what's 32 minus 5? That's 27. So that's the cube root of 27 plus 4. Does that equal 7? Well, what's the cube root of 27? Well, that's 3. Does 3 plus 4 equal 7? Yes, it does. So there's my check. All right. So again, we just want to make sure our radical is isolated. If it's not, like if there's something over here, you know, add. If there's something in front, divide by whatever's in front. So you have just the radical all by itself equals a number, and then you would either cube or square both sides, whatever the situation is. All right, so there's 3 pretty straightforward examples. And in a moment, the next video, we'll try some more complicated ones.